Okay, today we're going to do a little bit of review about some things that we actually are already doing really well as fourth graders, but we need to review them so that we can use them to a deeper level. Okay, we're going to talk about this sign and this sign. Okay, this sign means equal, right? The equal sign is telling us that something is the same as something over here. There's always two sides of an equation, right? This side and this side. And the equal sign in the middle is telling us that this has to be the same as this. They have to be the same value, okay? The numbers don't have to be the same, but when you do the math on both sides, the value should be the same. The quantity should be the same, okay? So the same way goes for this symbol. This means not equal. So something over here is not the same as something over here, okay? We have to remember to use those because we want to make sure that we can look at a problem, and if it doesn't work, if it's not balanced on both sides and have the same value, then we could show that it's not equal by drawing that symbol, okay? The other thing we're going to talk about as a reminder is these two math processes, addition and subtraction. Okay, again, easy, right? You've been doing this for a long time. Let's remember for just a second what we're doing when we're adding something. When we're adding something together, we're taking a part plus another part. We put them together and it makes the whole. Okay, so we're taking a little bit and putting them together to make a whole. We can draw a picture to help us show what's happening here. This is a math mountain. I like to show that it has a part and the part, and when I put those two together, it makes the whole on top, okay? These pictures in this sentence goes with addition. That's what we're doing. We know that when we put numbers together, we're adding, and when we add, we get a whole that's usually bigger. So this is going to be the biggest number, and this is going to be the bigger number. Out of all of these numbers, it's the big one, right? When we're doing subtraction, we're doing an inverse operation. Inverse means if this math, adding, is putting things together, inverse, the subtraction means we're taking those things and we're pulling them back apart, okay? So subtraction means we're taking the whole, we're taking one of the parts away, and we're going to be left with the other part. And we can make a drawing for that one too. It could be called a break apart drawing. It's very similar to this one. So in this time, we've got the whole first. We're taking a part away, and we're trying to find the missing part. Okay? So these two work together. They're kind of the opposite of each other. One of them puts it together, and one of them takes it apart. So you could use a math equation, and you could use the addition and the subtraction process with the same equation to show how they go together and how they come apart. Let's do that here. We've got 81 is equal to 72 plus 9. Okay, so if we look at this equation, we can see that we're adding. We know that from our picture that we drew, that when we're adding, we're putting the parts together. They're the smaller ones. They go together to make a bigger whole number. So we know that this is my whole number, and these are my parts. I could write it this way with my whole number first, but see how he's on that side of the equal sign? Because the value over here is 81. If it's truly equal, the value over here is 81 too. Let's do the math and see. 72 plus 9, 9, 10, 11. 72 plus 9 is 81. So I can see that this side is the value is 81, which is equal to this side, which is 81. Okay? So I could write it this way with the whole going first, or I could write it this way with the parts going together and the whole being at the end. It's the same thing. I actually flipped it on other sides of the equal sign, okay? I could also now I've shown the two ways that I can put this together. I could use the property to flip these two, because remember how the commutative property says it doesn't matter who goes first when we're adding. So we could have 9 plus 72 equals 81. We could also have 81 is equal to 9 plus 72. Look at all the different ways I can show that. The total can come first, and these guys can flip-a-roo, or the parts can come first, and then they can flip to show the total. Okay? Now, if we're talking about the inverse, let's make a line right here. That was all the addition. If we're talking about the inverse process, we're talking about subtraction. Now, we're going to try and undo or take apart what we did over here. So this time our drawing is going to look like a break-apart drawing. This was a put-together drawing. This is a break-apart drawing. So we're going to have we know about our 81, and we know about our 72. We're trying to find the other part. Okay? So if we're subtracting, we're taking the whole, 81, and we're taking away one of the parts, 72, and that leaves us with 9. I can write that a new way. I can switch the parts around. 81 take away 9 equals 72. That's the same thing. Or I can flip them around that equal sign so that this side is over here. So I could have 72, whoops, is equal to 81 take away 9, or 9 is equal to 81 take away 72. See how I flipped that around so you can see that I can flip the parts, but I can also flip the sides of the equation, the equal sign sides. Okay? You can see that my whole number has moved around. See how he's moved where he is? Sometimes he's at the front of an equation, sometimes he's at the back on the other side of the equal sign. Okay? Now, we've talked about how adding is putting things together, subtracting is breaking them apart. My whole number is 81. I could break him into these two parts, 72 and 9. I could break him into other parts too. I could break him into an 80 and a 1. I could break him into a 73 and an 8. There's lots of different ways I could break him, okay?